Hello and welcome to this August 30th evening edition of the SkyTour LiveStream, coming to you from the John Zack Memorial Observatory in picturesque northwestern Connecticut. Tonight we're going to explore the beauty and mystery of the universe as per usual, from nebulae of various kinds to the different kinds of stars that make them shine. We're going to see it all because that's what we do here at SkyTour LiveStream, and as you know, we will take questions from the chat room, so feel free to participate. And if you want to see a specific object, let us know. One of our moderators, probably Amanda, will see if it's up with me and we'll check it out if we can. And it's all live and it's all uncut. Now the system is acclimatizing, getting cooled off to ambient. So we'll be right back as soon as that's ready and we'll be going. Hey there folks, how you doing? Welcome to the SkyTour Livestream. Tomorrow's a big day, it's the eclipse day, and I'll be watching it, and if I can, I'll be streaming it. But we'll be talking about that a little bit later, and we're going to talk about some tips and ideas for you to stay safe when doing this, because people don't realize just how bright that sun really is. Even when they think they can look right at it, they can't. There's a lot of cases, and I used to tell people for years and years about this, and used to show them eclipses for years. And it's really, really dangerous to stare at the sun anyway. But when your eyes think you can, and you do it, then you go home later on, and in the evening you say, "What's that cloudy spot in my eye?" You don't notice it right away. So anyway, welcome to the SkyTour Livestream. And I believe Amanda is here. Amanda, you there?
I am here.
She is here.
Just saying hello to everybody joining us. Once again, thank you for the love and support.
Absolutely. Now, tonight is it is clear, but I warn you, it's actually humid. So I can see the moisture in the air, but directly overhead, I still have my Milky Way, and that's what I think is wonderful, and that's what keeps me going. So we're going to do our best to try and look at some objects in that Milky Way, and we will have fun tonight. Now, right now on the screen, you're seeing supergiant Antares, the Eye of the Scorpion. And this star is really a massive star. We've talked about it before, but the star is so big that if you put it in our solar system, it would actually go out to the orbit just over beyond Earth, and it's really a massive star. Now, in terms of its distance, Antares is actually pretty far away, and I don't know if anyone in chat knows how far away it is, but we'll talk about that. And as a red supergiant, this star is near the end of its life, and it is actually probably could be. I don't know. It's got to figure its mass, and knowing its mass, we could figure out what its end life is going to be. When stars are a certain limit in size, they start when they actually blow up into a supernova. They have to be a certain size to do that. When they blow up in a supernova, they return a lot of those elements to the interstellar medium, and that's what populates our periodic table, as we've talked about before. But Antares is an interesting star. It's red because its temperature is cooler. And you might think, well, wait, if it's a supergiant, shouldn't it be really, really hot? And the answer is, not really. It's bloated up really large. And because it's bloated really large, its outer temperature is actually quite cool. It does have, though, a really fierce stellar wind. Okay, like our sun has our solar wind. Antares has quite a stellar wind. And there's a cloud of gas and dust around Antares, and Antares is sort of embedded in a cloud of nebula and so forth. Now, to see that, we would have to take a longer exposure at a much lower sensitivity, so that we could actually see that. So we can't see that, not tonight this way. But it's interesting. It takes it gets its name because of its distinctly red color, which compares to that of Mars. And some people mistake Antares for Mars in the sky. Now, in Roman times, the star was actually called Cor Scorpionis, and it meant the heart of the scorpion. And they were behind the Assyrians in their mythology and so forth on Antares, which they also had laid out some mythology, and as did the Babylonians and the Sumerians. So obviously, for several millennia, the star has been there just as we see it. And in ancient Arab tradition, it's still the red heart of the scorpion. So Antares
is this.
Go ahead.
Is this also known as Anti-Aries?
Anti-Aries?
Yeah.
Oh, you got me. Where's that
I
come
thought,
from?
I don't know, I thought maybe Daryl said that once in chat, because you were saying people confused it with Mars, and Mars was Aries in Greek mythology. So it was the Anti-Aries?
Oh,
Antares?
well,
No? I could be wrong. I thought I either read or heard that. I could be wrong.
The Greek name for Antares means rival of Mars. So
yeah,
it could be something like that. But that's the Greek name, and maybe it is Anti-Aries. I'm not sure. Sounds like a relative. Anti-Aries over here. But that's pretty cool. And of course, Mars is the god of war, and red means blood, and that's of course
Well, exactly. I hear Aries, I think of Greek mythology. So then Anti-Aries, again. Yeah. I like the mythology. It's easy for me to remember.
Well, then you'll like the fact that the star had a different name in ancient Persia. It was called Satevis, and Satevis meant Satevis was the name. It meant it was one of the royal stars, one of the 4 royal stars. And if you look at it, the Persians had royal stars, and one of them was Antares. And when you look at it in the sky, you can see why. It's really, really prominent, and it's amazingly bright. So it's really neat. And Antares, by the way, is 550 light years away.
I was gonna say, Jeff Lucas said 553 light years.
He's exactly right. Now,
wow, good job, Jeff.
What does exactly right mean? Okay. Everything when we measure distances to stars, they're always estimates, aren't they? And once again, I have to say that I apologize. The construction on the main road, which is a mile away, is still going on, so they're still sending everybody up my street. So I apologize ahead of time for the
I didn't
people
hear too bad yet. That's good.
Well, that's good. So, interesting thing. Antares is actually, if we look at its spectral class, remember OBAF GKM, Antares is classified as an M2. Alright? And it's got a very low surface temperature, as I said, of 3,500 degrees Kelvin. And that temperature gives it the red color. The lower the temperature, the redder it is. The hotter the temperature, the bluer it is. Hottest are blue, coolest are red. And that's what we see all the time with the universe and these stars. So, that said, the visual brightness of Antares is around 9,000 times our sun's. That's incredible. All right, it's actually almost 10,000 times our sun. But it radiates a lot of that energy, okay, in the infrared. So that's another thing to keep in mind. When we look at stars that are red, we have to keep in mind that the spectrum doesn't just stop with the red visible light that we see. It radiates off into the infrared as well. And many M-type stars, M-class stars, will do that. And Antares is no different. It does the same thing. So.
And you said it was a red giant? Or a supergiant.
It's a supergiant. In fact, such a supergiant, in fact, that, you know, if we did replace the sun with it, it would go all the way out to the orbit of Mars. So that's a massive star. Remember, that's a spherical volume filled with seething cauldron of plasma and stellar core temperatures that are in the millions of degrees that are actually, fusing the new elements in our periodic table to come. So it probably doesn't have a whole lot of time left, actually, to be honest. And Antares is probably going to explode in a supernova, and that's not unexpected. Antares is definitely massed to do that. And like all these supergiants, okay, once they get to this point, their fusing cycles are very erratic. So the star can actually be stable and then go off kilter, so to speak, and they'll become what are called variables, and they will vary. Now, it's because of the nature of the variability, sometimes it's fairly periodic, all right, but sometimes it's irregular. So you have irregular variables and you have regular variables, all right, and but it's really cool. And I don't want to belabor Antares, but it is the really good starting point for tonight. Now, this is a photo we're looking at right now. I took it earlier, but I'll show you the live view. Okay, this is the live view of Antares, and if I do the 4K video view, okay, let's go look at it in the 4K video. So this is the live 4K video. So now you're seeing Antares live in the sky, and it's actually surrounded by a cloud of nebulosity, that is nebulous material. And this nebulous material is something that, again, we would need a little bit darker sky to see, and it wouldn't even be with our eye. It would only be telescopically or photographically. But I don't know. I think it's still cool nonetheless. So that said, let's move a little bit and see if we can go to another object that might be really interesting to see. I mean, I know we can. I just want to get there. So all right, we're going to move now. There it is. Again, we're watching it in 4K video live. So, oh yeah. Okay. Alright, this is a really interesting cluster of stars. This cluster of stars, which is actually in the southern sky, not too far away from Antares. This is called Ptolemy's cluster. That's Ptolemy, P-T-O-L-E-M-Y, Ptolemy. And this cluster is really interesting because of the fact that it sits right within the southern Milky Way, and it's really a beautiful cluster. And I really, really enjoyed Ptolemy's cluster. Now, if we look at the cluster itself, all right, it has a number of bright stars that we can see. And again, we're still in 4K video mode. So let me try and hold on. I was just trying to focus, but I need to zoom in to focus a little more, so let me just do that. So I'm going to shut off the 4K video. Alright, and it's more dramatic, isn't it? Now let's go in here and let's do a little focusing action. So 1 second. Okay, so move over a little.
And Jude is here. Oh, I hear an echo.
You do?
Jude's here from FX Models.
Yeah, she's from
Planetary Replica Division.
Yep.
Check it out on Facebook. I'll get the link.
Yeah. We actually we just got some beautiful Oh, okay, jeez. I thought the telescope was making a squeaking noise, but it was actually a truck. Yeah, I got a. I had an order sent out to them that we got these beautiful luminous spheres that are rechargeable, and we're going to use those at Devil's Tower. I'm not telling anyone how yet because that's the mystery. So there's a close-up of Ptolemy's cluster, and I just think the cluster is really so nice. I'm going to take an exposure now that's I'm going to do a 8,000 ISO exposure for 1.3 seconds. Let's see what we get. Okay, we can go to a little more than that. Let's go. We're going to say 3.2 seconds at 8,000. Let's see what we get. I'm going to go even more. 5 seconds, and I'll go to 10,000 ISO. 5 seconds at 10,000 ISO sensitivity. Wow. Okay, it's a little, just put this right at the limit, basically. I'm seeing there's some bright flashes over the horizon. Actually, quite a lot of them. So I believe that it's a. This is what happens when you actually see a moisture-laden sky at night, and then when the sky is moisture-laden and there's a fireworks display going on somewhere, it lights up the moisture in the air like crazy, and so the whole sky just gets this massive glow that just shows up. Kind of looks apocalyptic, like, you know, oh no, it's the end, something's happening. But let's talk more about Ptolemy's cluster then. The cluster is actually 980 light years from here, okay, and that's a really nice size cluster. And it sits kind of low to the horizon, which is why it's sort of detail free here. But it does have a number of interesting features, like just to the upper left, you can't see it in this image, but to the upper left there's actually a dark nebulous little snaking object that is there, and that's actually a molecular cloud, it's called. And the molecular clouds are actually very important because they serve as the basis and the source material for planets and stars even to form. So it's raw materials basically. So it's really cool. And at 980 light years away, you can see that it's actually quite a spread. It's 80 arc minutes in size. So if anyone wants to do their calculation with that number 206265 I told you about, you can go ahead and do it. But so that's Ptolemy's cluster. And again, it's down it's down there in Sagittarius or so. No, it's actually in Scorpius. I apologize. It's really close to the border. And then I want to take us to another object right near it. And this one is one that I have actually been asked to look for before, and now we'll look at it. This is called the butterfly cluster. Wasn't it Daryl that asked for this?
Possibly.
Yeah, I think Daryl.
Not sure where he is tonight. I think, is it near the Veil?
No. This is actually nowhere near the Veil. It's actually way in the south. It's down south. It's in the southern sky. So,
I don't know. Maybe I was thinking because the Veil we had to break it up into two separate pictures.
Oh yeah, well the Veil's huge.
Maybe that's why I'm thinking the butterfly with the two separate wings.
Oh, okay.
Well, we'll see how big this is momentarily.
Yep. And as you can see, this is the butterfly cluster, and there's an interesting star in here that I want to look at, and that is, well, first of all, let me show you the cluster so you can see the cluster directly. Okay, there's the whole cluster. Now, the cluster This the butterfly cluster, as we saw, the other one was 980 light years away. This one is actually almost it's almost 1600 light years away, so it's quite far. And then if you look to the right, I'm sorry, left, you see there's a red star in there, and there's that one red star. Now that red star may be like the others that we saw in the past when we saw double stars that looked like they were doubles, but they had different ages, remember? And that showed us, that told us that the stars couldn't have formed together, and that this was a visual double only in those cases. And that we call those visual doubles, meaning that we only see the stars looking like they're near each other, but they're not really next to each other, or gravitationally, and more important, gravitationally bound to each other. They're not gravitationally bound. They're only visual doubles because they're two stars close to each other in space. So that said, this star is likely an interloper. It doesn't belong in the cluster. It is from outside the cluster, or much more in the foreground, or could be in the background. It could be a very luminous star in the background. You know, we can't be sure in space. That's the whole thing. So when we look at the cluster, okay, as a whole, you see how that looks, and you see that the stars are all pretty much the same color, and that's a rough idea that they're probably they probably belong together. Then you got this one that doesn't belong there because it has this orange color, and that typically means that the star was actually a foreground object, or a star in the foreground or a background to that cluster, most likely in the foreground. But I think that's it's a beautiful cluster anyway, and it's a little gem. When you see it in a telescope, it's a gem. Let's go take a look at it live. Now, let's do it in 4K video. Okay. So now you see that cluster. Look at it. It's like a jewel box, and you know that red star to the upper left is just beautiful. And it really, really imparts this nice color, and it's beautiful to look at, and you can just stare at it. You know, play soft music and just go, oh wow, you know, it's just such a beautiful, beautiful cluster. And you know, that's part and parcel for, you know, getting into astronomy, and that's why people get into it, because they just like to look at beautiful things. Now, we're not too far away from this next object, which we've seen before, and we're going to go there now. There you go, and you can see we're in 4K video mode, so you can actually see the nebulous detail directly. I'll go a little higher just for fun. Yeah, that's almost a little too high, but that's okay. And this is M8, Messier 8, the Lagoon Nebula. And the Lagoon Nebula is really just beautiful, and obviously it's a stellar nursery. It's the place where stars are born. And I did want to tell you about that one spot in this stellar nursery that is important to us. And I'm going to just stop here and take a quick photo, 5 seconds, at ASA or ISO 51200, so it'll be a little bright. But I want to show you. Okay, too bright. I'll come down. Well, let's drop it to ASA 12,800 for 6 seconds. I drop a few stops and go up one. Okay, now when we see it again, I want to zoom in because I want to show you. Oh wow, look at that. Oh, holy cow. You know, moist night or not, it's just beautiful. Just beautiful. Wow.
I'm so glad you're so happy with the pictures you got.
Oh,
that makes it all worth it.
Well, you know what? In my mind, I keep thinking, wait till I get these in Arizona. Wait till I see this in Arizona. The Lagoon Nebula is going to be much higher in the sky in Arizona because we're farther south. Now, when you look at this, okay, you look at the lagoon, And you can't help but just notice that pink area on the right. It's actually the brightest part of the Lagoon Nebula. And it's being lit by a star that's of a certain spectral class. I've mentioned this before, and I'm wondering if people can remember. Do you remember, Amanda? What star, what type of star is actually lighting this one up? It's okay, it's not a test.
Hold on a second.
It's not a test yet.
Well, the Lagoon Nebula. No, I don't know offhand, but
okay. And no,
I would say
in the chat to tell you.
No, I'm not. I'm not looking. I swear.
That's okay.
I'm going through the little "Oh, be a fine guy, kiss me," and I'm trying to work out the color.
Yeah. Well, that's the thing. Okay.
I'll say K.
All right.
No. It wouldn't be K.
Well, you have to. It really. It's a sort of a trick question because the nebula is lit up very brightly, and that means that it's actually emitting its own light, and that's because the atoms are being really excited by a very hot star. And that star you see in the center of that pink area, that bright star, that star is actually responsible for lighting up that whole part of the nebula. All right, and that star I think is called Herschel 36, and it's actually an O-type star. So right at the very top, you know.
Daryl knew it.
Did he say so? Yeah, it was discovered.
Yeah, just now though.
Yeah, okay.
I swear I wasn't looking. I think they were waiting until I gave up.
That's fine. I'm not trying to trip you up here. But there, I mean, that's beautiful. Let's try a couple things now. Now that I've got this up here. So this is a stellar nursery, and you'll notice that the light that you see that's actually pinkish red, okay, is actually light that is, if you look at that with a spectral scope, like I have a spectral system here that we're going to use in the future to look at these things. If you look at those in that regard, you would notice that the pink area is actually emitting its own light. Now you might say, wait, does that mean it's a star? Does it mean it's giving off light like a star? It's giving off light, but it's not a star. It's actually a very thin gas. In fact, it's not very dense. It looks it from a long distance, just like clouds look very thick from the ground. But when you go up in a plane, they're very wispy. You can see through them. But when you look at this cloud of reddish pink, we're looking at a very thin hydrogen gas. However, that star that is striking them, the hydrogen atoms in that cloud, is very intense. And that radiation is actually causing the atoms to absorb at a certain frequency, all right, energy. And then they don't want to stay there, they spontaneously give it off. And when they give it off, they emit a tiny little bit of light. And that light is in the red end of the spectrum. It's called hydrogen alpha. I'm sorry, H2, okay? You know, it's doubly ionized hydrogen. So when you see this H2 region here, this ionized hydrogen region is an indicator of a very hot star nearby. Sometimes you can't see the star, and sometimes the star doing the lighting is at some other distance away that seems odd. And that's because we can't, we're not privy to all the 3D arrangements of the stars, so we don't know exactly where they are relative to each other. So sometimes it looks like the star way off to the side that is lighting up the nebula way over here. You shouldn't be able to do that, okay? But it's true, it does, and that's just something to get used to. So now that I said that, I'm going to try something here.
Oh, we do have a request if it's up and clear enough to see.
Sure.
The Trifid.
Oh, I'm going there next. You guys, here's something else. Here's something else.
That was from, I think that was from Ronald. Yes, Ronald.
Okay.
You see, I think it was the purple that threw me. Because I was thinking, in the little "Oh, be a fine guy, kiss me," that the first letters were more the red, and then it kind of went orange, and then it kind of went white.
It goes the other way. It's white to blue. I'm sorry, blue to white to yellow to orange to red. The left, it goes from hot to cool.
Oh, it starts at blue. Oh, okay.
Okay, it's O when they're hottest. So let's take a look at that photo I just took.
Okay. No, that makes sense. That makes sense. Okay, I was thinking of it backwards. That's why I guess so low down. I was thinking O would be. And G is like our sun, right?
Correct. We're a G2.
Yes, okay.
We're a G2, and we fuse hydrogen to helium normally. So that's a dwarf. We call it a main sequence dwarf, which is a Roman numeral 5, which is a V. So it's a G25, G2V. You know. So if you look at the lagoon here, one of the things you can see is that dark lane crossing the center from left to right, and you see you see that it's actually in front of. It looks like it's in front of, and it is. It's in front of a brighter nebula behind. Well, that dark area is actually not an absence of the lit gas. It's a dark, dusty lane that's blocking the bright nebula behind it. So that's how you think of this. And let me see if I can take another photo to make that even clearer. You know, I can do that actually, but I might need a little extra minute here to set that up. And I'm gonna do that actually. I think you'd like to see this.
Okay, well, while you're doing that, Ronald has a question about Antares actually.
Okay.
When Antares ends, will this affect us at all, and will it still produce new stars after?
Very good point. No and yes.
Cool.
So, in other words, I'm shutting off the camera for 1 second. I'm removing it, and I am changing to a special view system here that might help us see better. When Antares explodes and goes supernova, one of the things that's going to happen is it's going to send back into the interstellar medium all that wonderful material that it has made in its core I'm not sure of the age of Antares actually, but for let's say billions of years. And if that's the case, there's going to be a lot of it. And Antares is going to be returning to the interstellar medium quite a bit. All right, let's do a 15-second exposure. I didn't even refocus, so they're not going to be focused. So I should have focused. I'm excited. See, I want to try this, and it's like, oh, I should have just focused the darn camera.
I'd say a lot of people would be like, no, this is how I have it set up for the night. Maybe on another stream we'll do it, but you're willing to do things on the fly. Don't worry. We'll be patient.
Wait until you see this.
You're still providing good information with the black screen, so don't worry about it.
Look at this. This is really cool. This is interesting. Because now you can see the colors in the nebular stars. That's really, really nice.
Wow.
So see, serendipitous. It's a serendipitous thing. I forgot to focus, but it's to your benefit. Because now you can actually see the actual colors of the stars in the nebula. And you can see they're very different. Look at the blues. Look at that. It's just to the center right, there's a star that's looking pretty blue, and then above it's a star that's less blue. The intensities are very, very different. So, that said...
But is this like if you took a normal picture and purposely defocused it, yeah, this is what we would get, right?
That's correct. We could get the same thing.
Okay, you just jumped the first step. That's amazing. I mean, I don't know. If someone just looked at that, never in a million years would they think that was a nebula.
Well, they might not know, you know?
No, I wouldn't even know they were stars.
But it almost looks like an art project, doesn't it? It's almost like an artistic project. It's really cool.
It's gorgeous.
So now, let's do this. Let's move over a little. And now we're going to do a 15 seconds at 80,000. So it's going to be a little bit grainy, but I want to see what we're going to get with this special filter in here. Now the filter I'm using is filtering out the light pollution that's down near the horizon. So we're going to compare this photo to the previous photo we made. And I can tell you that I used it way too long in exposure, but holy cow, we get more detail. Check it out. I know this is bright.
Mario would like to know what make and model camera you're using.
This is a Sony brand camera. We're using the Exmor sensor. It's an A7S II. Modified for astronomical work, of course.
That's gorgeous.
Yeah, and now we're going to go down to 8,000 and do 15 seconds at 8,000 now.
And I'm sure you're going to get to it, but Jeff would like to know, why is the star blue?
Well, the colors of the stars are actually based on their temperature. They actually, if you look at, it's what's called a black body radiation curve. The ideal, oh my god. Oh, sorry guys, I just lost it with this. It's just beautiful. Oh, okay. This is, oh my god. I don't even know. I'm at a loss. This is stunning. This is stunning. Oh,
it's
wow.
beautiful.
Look at that. Stunning, stunning, stunning. Wow. Okay. Let me try to compose something here without sounding like a dummy here. Okay. When you look at...
sit back and enjoy it. You're allowed to sit back and enjoy it.
I am. I'm enjoying it like you wouldn't believe. This is really good. I love that. Look at that.
Gorgeous. And actually, that'll definitely be going up in your Facebook group. I'll grab that link and throw it in chat now.
It will, but I'm actually going to do better than that. That's at 8,000. I'm going to do 25 seconds at 8,000. Let's dare to see what that'll do. I mean, there's a certain point at which you can overwhelm your filter as well, and maybe that's what I'm going to do, but we're going to see. Man, jeez. Wait till we compare, and you'll see what I mean. Ay, ay, ay. Waiting is just nerve-wracking. I'm waiting. Show me some. Whoa!
You said some of this used to take hours or days, and you're getting it in seconds.
Well, not.
You're too spoiled now. Wow.
Oh, I'm sitting down. This is just wow. Just wow. Folks, this is the Lagoon Nebula, and that black molecular cloud you can see very clearly now is basically in front of the nebula, and the general lit nebula is behind it. You can see that so clearly. Is this not the coolest thing? Wow.
That's beautiful.
Jeez. I can't wait to do the Trifid. Oh, we're going to do the Trifid too. Woohoo! Oh, I'm going to do another one just now because 25 seconds at 8,000. So
I'm glad we had a follow-up question and came back to this.
Yeah.
We were moving and you came back.
Yeah, well, I'm glad I did because I only thought just now, a little while ago, I should try this filter. This is just
it's a nice filter.
Stunning. The Lagoon Nebula is 4,300 light years away, 4,300 light years away, and that O star is lighting up, several light years around it, literally. And I'm taking the sequence here, so that's why it goes black every now and then for 25 seconds. And so this, I just can't believe it. It's like Mixie, that's it. I'm not going to go to bed tonight. I'm going to stay up. I'm going to photograph the sky all night long, I think. Yeah, no, I won't.
I hope you brought woolly socks out to the dome.
My telescope is going to...
Oh, yeah, they do.
Yeah. Well, I made...
Did you bring a hairdryer?
I do. I have the hairdryer, but I also have... I made a dew cap, which is I made this special cover for it out there. Look at that. Oh, my God. Look at the detail. Look at this little... Look at that little globule right there in the center. Just above center. I'll try and move it in. Right there. It won't quite go to center, but it looks like a little running rabbit or something like that. I have not seen that on any of the other pictures I've taken of the lagoon. This is just absolutely oh my God, it's like looking at a picture, a photograph. Well, it is a photograph. No, it's like looking at a picture in a book. It's just spectacular. See, and it's a matter of the right equipment too, you know. And this, again, this is seen through the filter that eliminates the glow of the sky. You know, I'll do another one. Oh, we're gonna do the Eagle. We're gonna do the Trifid Nebula. Oh man, I'm telling you. So, let's talk about the lagoon. Since I'm trapping you here with me, you know, the first time it was seen was by a guy named Giovanni Battista Hodierna, and he was, and that was well before, that was before 1654. So this was, you know, a long time ago. The lagoon was seen, and you can't miss it. You can actually see it with your eye on a clear night, a very nice dark night, and it was actually, you know, Flamsteed, who was a guy who was a brilliant man who cataloged stars and so forth, John Flamsteed. He actually he called it a nebula back in 1680, and so because it was obvious that it was a nebula. You know, look at, jeez, every time it comes up, I lose my breath. I'm sorry. And he called it a nebula as well, and you know, the later on, it was actually, with a telescope, it was actually able to be resolved into stars with nebulous, we call it nebulosity, nebulous you know, clouds around the stars. And then it just was observed, and more people caught onto it and saw it and started cataloging it. And then in 1764, guess who came along? Charles Messier. And he actually described the cluster primarily. He actually talked about the cluster as being important, but then he actually mentioned the nebula separately. All right, and that was something that's interesting because you know, the nebula is only identified as Messier 8. Okay, but it was actually the nebula and the cluster that Messier ultimately included in his listing. No, that's just a little history for you.
Well, yeah, because Ronald was asking, why did Messier get the credit? If he kind of built on someone else's idea.
Well, yeah, I know, but that's the thing, you know. You know, well, I guess because they didn't want to say, you know, they didn't want to say that you know, this was, you know, Giovanna, you know, Battista Hodierna's nebula. They say Messier 8. Oh, okay, that's better than saying Giovanni Battista Hodierna 8. Well, I don't know. I'm being funny. But it's hard to be funny when this is so beautiful. It's like, geez, man. Just stunning. One more, and then I promise we'll go. We'll go to another nebula. So this is, like I said, again, this is 4,300 light years away. And the really interesting thing is there's a beautiful Hubble Space Telescope photograph of the heart of that nebula, which is that pink area to the right, and it's actually the area where Herschel 36 is, the star that's actually lighting it up, and that is actually this area, you know, right there. Now that's actually, you know, they call that like the hourglass or whatever, and it's an interesting feature of the nebula, and it is a fascinating location. It's just fascinating to watch and to see this nebula. Now, here's what's interesting. If we were seeing a supernova, I'm going to go to 4K 3D, 4K video rather. I just want to bring it in with this filter. Oh yeah, it's much more prominent with the filter. Holy cow. Okay, how about if we go up to the Trifid? Shall we go to the Trifid? Yes,
sure.
We shall. Alright, now it's 25 seconds at 8,000 that we've been using, so I'm going to go back down there and use the same one for the Trifid, because it seemed to work. Any questions about the lagoon, let me know. I'm happy to go right ahead and tell you more.
Where did the word nebula come from?
Well, you know what? back in the early days, a nebula is it's a term that meant cloud. All right, and so that's exactly what these are clouds. Now, no one knew what they were composed of at all, but they just knew that they were clouds, and so they became clouds, and thus nebula, plural nebulae, Nebulae. Let's go in here and I'm just bringing it up here. Okay. I'm gonna just drop this down to a very short exposure at a very high ISO just to see what I've got here. Oh, wow. Wait until you see this one. It's actually horribly grainy, but it just gives you an idea. I thought that's where it was actually. So I'm going to do 25 seconds on this one as well. So let's move over there now. Okay. Let's try this. Here we go. So, the Trifid Nebula is actually an interesting guy because it looks like it has these 3 bright lobes. But in fact, the Trifid actually has a very regular nebula, okay? And that nebula is actually being blocked by a area of molecular clouds, and that is what those 3 lanes we see in the Trifid are. So when we look at the Trifid, we see this. That's exactly what we're looking at. We're looking at these dark molecular clouds blocking a brighter nebula behind them. So you can see that space is anything but homogeneous. It's actually got all kinds of little intricate patterns and dust and all kinds of things in it. And that's actually fascinating, you know, when we look at it, because we don't know what to expect. And when we see space and it looks dark, it's not necessarily dark, you know. So there we actually see these 3 lobes very clearly. Very clearly. And we have a bluish nebula up here, and we have a red doubly ionized hydrogen, H2, that is in, you know, II, that means, you know, the Roman numeral 2, H2 region here, powered, of course, by those stars. Boy, is that pretty.
See, I like this one because it's one of the ones I can actually identify.
Sure.
Like if you gave me a bunch of pictures and a bunch of names,
yeah,
I could get this one.
Well, you know, the stars that are powering this, and the blue star, sorry, the star that's causing the reflection nebula, the blue one at the top, just out of shot here. Together, these things are brighter, sorry, not brighter, but as big as the full moon. That's how big they are in the sky. Okay, and that's pretty good for something 5,200 light years away. So that's not bad at all. Wow, that's something. I'm gonna do a little extra something here. I'm gonna go up to 12,800 and go 25 seconds and see what.
Okay. We have questions. I'm not sure if I'm going to be wording this right or not. Okay, the lighted cloud is gas. On the Pleiades is the blue light caused by the same reason.
Well, actually, the blue light of the Pleiades is lit for the same reason as the blue light here in the Trifid Nebula. Okay, and I'll show you that in a sec. Okay. Because I'll go up to it.
And then we have another request coming after this, but we just got here, so let's enjoy this for a while.
Yeah, I mean,
good picture.
Yeah, it's nice. So now, when you look at this, you can see the Trifid Nebula there, but now I'm going to go up now to the blue thing. There's the blue part of the nebula. That blue part of the nebula is a a nebula that is generated the same way as the nebulae in and around the Pleiades. This is called a reflection nebula. And blue nebulae are reflection nebula, and red are H2 regions. Now, the difference is very, very striking. A reflection nebula maybe could have been an H2 region if the star was hot enough and there was enough hydrogen in the area. Certainly, the hydrogen gas isn't confined to just this little area down here. Certainly not. There's certainly hydrogen gas up here as well. However, the gas in this region here has not been excited to a high enough temperature to start absorbing radiation and then spontaneously emitting it as this region does here. So when we look at this, we're seeing this is an emission nebula, it's called, and this is a reflection nebula. Two very different things, but they can be right next to each other in space, and one could taper off to become the other, and that's kind of what we're seeing here. The red emission nebula sort of tapers off into the blue nebula. See? So that's a really interesting feature. I'm just gonna go back to that photo for 1 second. Yeah, I'm a little high. I'm gonna bring that down. I am gonna go.
I see lots of reds and pinks.
Yes, you do. Indeed, you do. Okay, this is 25 seconds at 12,800. And we're going to see what happens. The Hubble Space Telescope has taken some really beautiful photos of the Trifid Nebula.
As beautiful as yours? I doubt it.
Oh, no, much better than mine. I mean, it's in space. It doesn't have an atmosphere to deal with. Now remember, this is Messier 20. Charles Messier called this Messier 20. Again, it was the 20th object that he wanted you to avoid if you're looking for comets. And I always find it amazing. That's just another nebula, whatever. It's like, wow. But it was discovered by Le Gentil before 1750, and then Messier added it to the catalog as the 20th entry. And that was in around 1764. He called it a cluster of stars. They were like the 8th or 9th magnitude, and they were enveloped in nebulosity, which is what we talked about before. And now, so that...
Mario has a question.
Sure.
Do they move at all, or have they been the same for millions of years?
Well, the stars and everything is moving through space. Everything is moving. There's nothing that sits still in the universe. Nothing. Except you, if you want to consider yourself a reference frame. But all your molecules are vibrating too, so you're not really still. Over time, the nebula and its surrounding environment will look different. And I would think that at the time, 65 million years ago, I would be willing to bet that the Trifid Nebula looked a little bit different than it does today.
What do you think it looked like?
Oh, we don't know. We don't know the motions of the gases in this particular cloud, but...
No, but based on what you know, what would be your best guess, if you had to give one?
I would guess that the dark lanes that we see, the molecular clouds, were probably in a different orientation. They're probably drifting in front of the cloud over time, in front of the nebula over time. Oh man, this is just you know what, folks? This is breathtaking, to be honest. Here I am, sitting out in the middle of an observatory, okay, and I got a sweatshirt on, and it's August, but I don't care. It's chilly out here, but you know what? I'm all right because these views are worth it, and I'm glad I can bring them to you guys. I really am. I think I solved the streaming issue, so I don't think we're going to have any of that stuttering that we had last time. Our stream should be pretty solid, and we shouldn't have had any buffering at all.
As everyone knocks on wood.
Well.
No, so far so good. I mean, these things happen.
Yeah, and
it could have been a YouTube glitch. It could have been anything.
Yeah. I apologize for that stream last time, guys. I didn't. It was. I'm going to tell you what it was, and it was all my fault, and it was really, really stupid. So feel free to berate me and call me all kinds of names. I probably deserve it. It was the fact that I had the Wi-Fi antenna sitting on top of my computer case here in the observatory. And the Wi-Fi antenna needed to be separated and taken away from the metal case to make it better and easier for the signal to reach me here in the observatory. And now I have it up against the wall of the observatory, and it's I'm getting 3 out of 4 bars with the Wi-Fi here, so it's much better. And thank you for letting me indulge in my getting multiple pictures here of this, because in the end you're going to benefit, because I'm going to put them up for you along with these raw photos and the processed photos. When you see the processed versions of these, it's going to be night and day, and I can already see them in my head, and I'm actually like, I almost want to like leave now and go do it, but I can't, because I have you on the other end, and I'm not going to do that to you. So that all said,
that would be something to do on a rainy night. Show us how you actually process these photos.
That's going to be something that I do, actually.
Oh,
I am going to do that.
Go.
I did one.
Sorry, am I ruining all the surprises by thinking out loud?
I did that once already, though, if you remember. I actually did. I did show people that. Now I just have to take down a note here. Let's see here. Let me take another photo. Hey, if I can write a note, I should be taking a photo. Okay, notes. I hope you're having a good time so far, even though I keep showing you the same darn object over and over. But I promise at the end of this exposure, I'm going to bring the photo up for you to see it, and I'm going to leave it up for a while.
No, there's just been nothing but positive comments. Every nebula has its own beauty. It's been perfect. It was Clem. Mark, you're awesome. Agreed. Yeah. Oh, we're blaming Clem for removing the Wi-Fi or antenna or whatever it was. Yeah.
Well, I didn't do it. Yeah, you did, Clem. Damn it, I think it was Eunice. No, it was you. Okay.
Jeff, if you are on Facebook, you can join this group. I'm just putting it in right now. It's the SkyTour LiveStream with Mark D'Antonio. It's the Facebook group, and the pictures he takes during the streams, he will put unprocessed up there. I mean, the odd time you do like a half and half, or you'll show both versions or whatever, but he has some unprocessed, so you can take them and play around with them and see what you come up with. And
that's right.
Yeah, so he was asking if there was a way he could get the processed pictures, so
that's how. I mean,
that would be your best bet.
The processed pictures are all going to be available online anyway, and I gotta tell you,
I think you should make a coffee book or something.
Well, you know what? I need to.
Picture book.
There's a lot of people that can make them with their work, and there's some that do far better work than I do when it comes to this stuff. And you gotta remember what I'm doing. I'm doing this for dynamic live view. People who make the coffee books, and it's a great idea, Amanda, don't get me wrong. The people that do the coffee books are actually, they're creating masterpieces, and sometimes spending hours working on these, to make sure that the images come out just the way they want. And we're doing this in 5 minutes. I mean, admittedly, we're using very, very high-end cameras, okay, and very high-end systems.
I think anyone would be pretty impressed with a book full of these pictures.
I'd love to think so.
I bet everyone in chat would agree.
Oh.
Just saying.
No.
Or maybe even a calendar, and you can give them out to your loyal subscribers.
Well, that I would do anyway. Okay, we're gonna go up to. We're gonna just keep right on going north in the Milky Way here. And we're going to the next site right now.
Oh, we had a request. Hercules HD 164595. Please and thank you.
Wait a minute.
Gary.
Is he saying HD?
Yeah.
Okay.
Like Hercules Delta. 164595.
Okay, we'll see what we can do.
Okay.
I'm going to just drop this. I'm gonna drop the exposure here briefly. I'm just gonna see what make sure I have what I want in here. It's probably gonna be near the top of the view. So I can't see anything right now, so I'm guessing oh, it's over there. Okay, great. Alright, so live view. Let's pull in. Okay, this, you all know, we have seen this before. This is the Omega Nebula. And we're going higher in the sky as we go, so the views should be better. And the intricacy of the dark clouds should be even better. Oh, I'm anxious. The Omega Nebula never disappoints. Oh, and it doesn't disappoint now. Wow. Oh, it does not disappoint tonight. That's for sure. It does not disappoint. Wow. Look at that. Intricate detail. Holy cow, that's just beautiful. Okay, I'm gonna do a couple of this, and we can also talk about the Omega Nebula too while we're doing it. This is a really cool nebula. I mean, it's literally like the others. It's over 4,000 light years away. It's 4,200 light years away, and it's actually it's an area where many stars are in this nebula that are actually illuminating and causing the hydrogen gas in the nebula to emit, in the doubly ionized hydrogen realm. And we're seeing that. I'm just going to show you the nebula just so you can see it for a second without being encumbered by me taking yet another picture. And what else I'm going to do? I am going to, for now, I'm going to get rid of the second small camp, so now you have a full view. Ah, that's really pretty.
That looks kind of scary.
What? My face on the full cam? Oh, I know, yeah.
It looks, well, we haven't zoomed in. Well, I haven't on YouTube yet, but it looks kind of like a black hole in the middle.
Looks like what?
Like a black hole in the middle.
Oh.
Not a real black hole, but it does. It looks like there's kind of like a hole shape of darkness.
Actually, that's a very good point. That's actually an area where a molecular cloud is reaching over the front of the brightly lit nebula. You know, that luminous nebula. So you are effectively...
Why is it so round?
It's just what it is. I mean, that happens to be what it looks like. Okay? And here, let's take a look at that for a sec. So when we zoom in on that, what you're saying is you're talking about this area right here. Right? Right in the center there. And that area is actually an area, it's a tongue of dark molecular cloud that's over the front of the nebula behind it. So if we could go out in space to the left a lot, we would see the rest of the nebula behind this, because that cloud is probably in the foreground. And below it is another tongue of dark nebula that's actually over it. Okay, and then over on the left here, down below here, there's another hazy layer of dark cloud and dark matter that's actually going over it. And then that border at the top is actually a dark dust lane that we see going through this whole region. So there's a lot of dark dust out there in space that we don't realize is out there causing all this, and that's what's doing that. That's really cool. So I'm gonna take another 25-second shot, You know, I'm sure the eagle is going to be gorgeous tonight. I'm really like I'm working my way up the Milky Way, and it's really really nice. And because I put the dew cap on, I don't have to worry about dew on the telescope for a little while anyway. Wow, that's so pretty. I'm gonna make a minor adjustment. I'm gonna bring it down a little bit, just to bring it down a tad. Okay, and now we'll take another picture. Now, there's an interesting set of observations about the Omega Nebula here. Now, it is lit up, but what's interesting is the folks that are researching this nebula seem to indicate that maybe it's not as much a stellar nursery anymore, and that it's actually gone into a different phase of its existence, where the stars are now using their stellar winds and are probably blowing dust out of the area, creating voids here and there. And maybe that's what's going on in this nebula right now. There's no more stellar production going on. That's one of the thought processes going on right now with the Omega Nebula. Again, 4,200 light years away. It's not close by, and all we have is its spectrum to analyze to figure out things in here. But it's just something else. I'll take one more. I'm really anxious to go to the Eagle. I told you it's going to be nebulae.
Ronald wants to know where the dust comes from.
Well, the dust comes from the fact that when the matter in a supernova, when the matter explodes out into space, there are shock waves that are formed. All right, and these shock waves are brought about by the expanding gases moving at supersonic and beyond speeds, obviously, away from the star, and they cause a shock front, and the shock front causes stuff to compress along the way, and that stuff that compresses are stuff that sorry about the noise, are things that have been there for a long time in the universe, and that is dust grains, very very small micron-sized dust grains. And these dust grains coalesce and they form heavier dust, and they form and they become molecular clouds, sooner than later, and they actually end up going into forming, planets and so forth later, or they become the raw material for stars. I mean, as soon as they get caught up in a star, as it gets hotter and hotter, the dust grains are broken apart, and the heat, that's so beautiful. The energy of the dust grains is such that they, can absorb a lot of energy, and then once they get, broken apart by the temperature, sorry, then at that point they become just the elements that are in the periodic table, and as they're just elements, they can be anything they want to be. Meaning that you can have potassium in a star right from the very beginning, because the elements form when the star forms. The elements are there when the star forms, and that's something that's really really interesting, because when we look at our sun and we see all the elements it has calcium in it and so forth. You say, well, wait, did the sun make the calcium? No, it didn't. But when it formed, there was a lot of calcium in the solar nebula from which the sun formed. So when you look at a star, its composition tells you a lot about when it formed and so forth. And stars of a certain mass, and only a certain mass, can make certain elements that we see in the periodic table. Above that, they're made in supernovae and merging neutron stars. And that process that causes the elements to be made in that way is something that is part of understanding the whole process of nucleosynthesis in stars, which is the synthesis of nuclear material, the creation of elements within the star's atmosphere and core. And you know, stars make up to as high as iron, which is number 26, which I've mentioned to you before in the periodic table. And beyond number 26, they can't make them. You know, that's the highest they can go. Why is that? Because iron, the iron is very stable. Iron can't be made into anything else without excessive amounts of energy and pressure. And that's exactly what you get in a supernova. I can't impress upon you how big a supernova explosion is and how incredibly volatile the area around the supernova explosion is. But I mean, just imagine something that can completely destroy an area like this that we're looking at right here. You know, a supernova explosion in here could cause a supernova remnant that's this size. That's massive. That's incredible. So you know, there's a lot going on, and now, as promised, I'm heading up to the Eagle.
Oh, don't forget about Hercules.
HD, the HD designation. That's the Henry Draper catalog. That's a star that he's looking for.
Can you not see it?
Oh, I didn't even try.
Oh.
I don't know yet. Okay, so now we're gonna go up just a little bit farther north. It doesn't take much to do that. Let's go into our 4K video. There we are. And I am guessing we're going to be going right here. Yeah. Alright. Let's come out of 4K. And let's do a 25 seconds at 12,800 and see what we get with our special filter. The filter is really particularly useful for nebulae. So, I mean, I just can't get enough of it. Now, there's other filters, and Daryl's actually sending one to me to try that specifically can show planetary nebulae very, very clearly, along with supernova remnants. Okay, this was just a little too much. I'm gonna take this down a bit, and I wanna thank Daryl for that. I know that he's definitely
he's in chat and listening.
I just want to make sure he's not gonna miss that filter too much. I'm gonna send it back as soon as I check it out, and then get one if I want to. I have a number of ways to adapt that to our system. Man, I'll tell you though, I would call this a very successful night, folks. Alright, still too much. That's good. I want to actually be able to drop it down more. Oh. Well, no wonder. I was 10 times higher in ISO than I thought I was. I apologize. That was wasted eyeballs there. Sorry about that. So this is the Eagle Nebula that we're on now. And it's a bright nebula that's in the constellation called Serpens, S-E-R-P-E-N-S, Serpens. And it's around 7,000 light years away. And it's also a star-forming region. It's also the region where the famous photo taken by the Hubble called the Pillars of Creation was done. And let me just go back to that for a second because I almost missed it. And let's zoom in and see what we got. This will help me figure out what we want. Wow. You can see the dark lanes that are moving diagonally from the lower left to the upper right. There's about 3 of them. Those are the Pillars of Creation that the Hubble photographed. And they are absolutely stunning in the high definition detail of the Hubble. And I'm just astonished at how beautiful they look in real life when you see them You can see them through a telescope with your eye, but when you actually see them for real on a photo that you just took, it makes them just unbelievable. Okay, this is 25 seconds at 12,800 ISO, or sensitivity. Now, the whole overall nebula has a magnitude of 6.4. Remember, magnitude is brightness. Now, it's kind of strange because, you know, in the magnitude scale, in general, almost anywhere else we do measurements, the bigger the number, the bigger the brighter the value, or the bigger the value, right? Well, it doesn't work. You know, it's not the same here. In astronomy, it's actually different. When we have a magnitude scale, it starts at 0, and when it climbs, then the stars are actually fainter. So about the limit for your eye is dependent on where you are. If you're in a very nice rural countryside, you might be able to see magnitude 6 stars. If you're in a city, you might see magnitude 1 or 2 at the most. Oh my gosh, that's just something. I gotta just show you this. This is beautiful. Oh wow. This is probably the best one so far. This is the Pillars of Creation as seen by the John Zach Memorial Observatory. My friend John would have been proud. I feel so bad. He died of cancer a few years ago, and that's why the observatory is named for him. And this was what I have in here is a project that you know, he and I were meant to do together as a automated project, and we just didn't get to do it. We met in Travelers Insurance Company, where I used to actually have a real job, as people say, and John and I were doing programming. Now he was a tall guy. He was like 6'3", and his wife was a little person, and so when you saw them together, it was like, wow, very, very tall guy, very, very little person, and she had a huge heart. She was a wonderful human being, and so did he. And so it was only a matter of time before we became friends and thought, hey, astronomy's so cool, let's do astronomy together. And we ended up buying a telescope, and my business of it was going to be to automate it and get it online so everybody could use it. And we were on our way to that when he ended up getting cancer, and he died. And so it sat in a box for about 4 years, and I just didn't want to touch it. I was like, I don't want to do it. I don't want to do it because it just didn't feel right. Well, I don't know why, but eventually I just said, you know what, I should do it. And I guess it's sort of like a rolling stone. It started getting faster and faster, and then I said, well, I should get a 2-inch adapter. I should get this. I should get that. You know what? I need this eyepiece. And you know what? I need a computer. You know what? I need a dome. And it just spiraled. And I said, you know what? I want a telescope pier, and it's got to be a pier that can hold this telescope permanently. I don't want to have to set it up, each time I want to use it. Okay? Because Paul down in Florida for P&K Skywatch, space imaging rather, Paul sets it up every single night. And admittedly they're only looking at the moon, so he doesn't have to be perfectly aligned, but I'm going to objects all over the sky, and I want them to be in there. So I spent the time, the money, and the time, did I say time? Getting this telescope lined up so that if I look at an object that's over in the west side of the sky, and it's 30 degrees above the horizon, we can look at it by just telling it where to go, telling the telescope to go there. And if we look at something in the in the south or in the zenith, overhead, directly overhead, or over on the eastern horizon, or in the north, this telescope should be able to point at that object and not ever miss it. So I spent the time to make sure that I got all the gear right and all of the calculations right, and I had to do my best to make sure that we could actually get this telescope perfectly aligned. I designed the pier with specific setup so that it's mounted on 3 bolts that are actually raised off the top of the pier, so that I can adjust them from underneath and adjust the level of the pier, or the telescope on the pier. So it's something that actually takes a lot of forethought, and I had to scour the internet and make a design that was actually gonna work. So, you know, all the piers that were out there, they were nice, you know, and they were really nice, but I just didn't want to buy one. I figured we can make one, and my friend Russell Schleich up at ENS Metals, right up at the top of the hill in the industrial park, Russ turned right around and made one. And as soon as the word got out that my telescope pier came from him, he had another guy come to him to get a telescope pier just, you know, a couple weeks ago, which I think is hilarious. So he's now getting known for doing telescope piers when he usually does, you know, metal railings and fabrications for big companies. And then you have this one guy come in and says, "I want a telescope pier," and he knows what he's talking about. You know, so
That's awesome.
Yeah, it is. It's pretty cool. So anyway,
and we're so glad that you decided to go through with it. That you decided to not.
Oh, just like
you decided to go it alone, even without your friend.
Yeah. Well, look,
his honor, and you're getting gorgeous pictures, and you're educating people, and you know, just doing such a wonderful thing. I'm sure. I don't know what anyone's beliefs are, but I think he'd be happy.
Yeah. I hope so. I hope so.
It's a positive thing you're doing in so many ways, anyway. So
I'm glad that you know, people do like it, because I actually you know, I would have done it anyway, even, you know, myself. I would have probably done it anyway, but I just think it's really neat to include other people, you know. Now, like when we
and actually you can see for everyone in chat, if you go to that Facebook group, I posted the link again in chat. You can there's actually pictures like way at the start of the group of the dome and all the work, like the pier that he made himself, and you know, all the pieces, the plaque, all the 3D printed images. So definitely check out that group.
Yeah, and that plaque.
See all the hard work he did for us.
See Jude, you know, who of course is FX Models Planetary Replicas out in Colorado. Jude was very instrumental. She actually did all the work in getting the plaque, and all I did was tell her the story I just told you guys. You know, that this was, I really wanted to do this. I wanted to do this and get this observatory running finally. And I had visions of just playing music like we're hearing now, but just playing it in the dome. And as I observed, and that was just for me. And I was thinking, wow, you know, I could share this with everybody. You know, and then that became, you know, Keith at P&K Space Imaging telling me, well, you should stream. You should start streaming. And I was like, well, streaming? Really? What's involved with that? And Bill Skywatcher said, oh, I can tell you. And he went on and told me all kinds of this and that. Next thing you know, Bill's over here in the observatory, and he's, you know, helping configure my mixer, which is the reason you can hear me, because of Bill New York Skywatcher. Okay, he helped me set this up. And, you know, I could have figured it out, I'm sure. But you know what? You have no idea how many separate things had to come together to see the view you're seeing now on the screen. Think about it. All it is a camera on the back. Now, it's an advanced camera, no doubt. But there's an HDMI output from the camera. Where's it going? Well, it's going to the computer. Okay, but the computer doesn't know how to read the HDMI signal output from the camera. That's true. So you have to buy a specific capture card that will actually capture the imagery and allow you to then display the imagery. Oh, well, then you got to display the imagery. What do you use? Well, you could use a program to display the imagery. But wait, how about when you want to stream? Oh, well, then you need broadcast software. Oh, broadcasting software. Okay. And what are the limitations on that? Oh, there's umpteen limitations. You just have to figure them out and figure out what the best thing to do is. So I ended up doing a specific, you know, it's a specific flow, a workflow basically that I use, and that workflow gets me to you, my loyal fans and listeners. You humble me every night by showing up, and I just shake my head. It's like, wow, you guys are really here watching this stuff. It's like, great. You know, it's just so cool. I really, really enjoy your companies, you know, because even though I can't see any one of you, I am indebted to you for showing up, because you actually have been very, very instrumental in getting this, helping me get this word out, and I will not ever stop. And I'm moving, by the way. I'm just going to another thing right now.
Well, I mean, the least we can do is show up and try to spread the word. I mean, you're putting in the time and the money and the effort and freezing to death and setting all these things up and calling all your friends and, you know.
Winter's coming, yeah.
So.
Yeah, no.
I mean, it's the very, very least we can do is share links and thumbs up and. Yeah. This
battery's at 5%. I just have I have another one in my pocket. Don't worry. All right, let's see. Now I'm gonna go up to.
And Judith's still here.
Yeah, well, that's why I said, you know, she actually is instrumental in getting me that plaque on the John Zach Observatory. She went the extra mile, you know, and that's like that's crazy. She's wonderful that way.
She said the plaque was a pleasure for us. John Zach was an important part of your astronomy past.
Yeah, that's true.
Thank you for that, Jude. And again, see, I can't link pictures in YouTube, but there is actually one. It's a close-up of the plaque, actually on the dome, when the dome was being set up in Mark's Yard. So
yeah,
definitely drop by the Facebook group. I did put the FX Model Planetary Replica Division link. Okay. Please join that on Facebook as well.
Thanks, guys. That's wonderful. Yeah, go see what we've done out there. You can see that we do these big giant planets that are, you know, 4 feet across and sometimes larger. We did a museum in Turkey, in Istanbul, and we built these gigantic. Planets that, you know, one of them was 55 inches in diameter, and that was Jupiter, and it was just crazy, you know, unbelievable. Great stuff. Great stuff. Okay, 5 seconds at 8,000 on the Wild Duck Cluster. We're traveling farther north, up toward Lyra and Cygnus. That's what I wanted to achieve. I just wanted to get just the cluster. That's pretty cool. So you can actually see the cluster itself, you know, and without any sky glow, too much stuff. But I'm going to give it a little. I'm going to go to just 13 seconds at 8,000 ISO. Keeping an eye on the battery life here. I've got 5% left on this battery. But that's okay. We can deal with it. Wow. What do we got? Oh, see, we're getting even more stars now. And if I increase the ISO to 12,800 for 13 seconds, then we're going to see even more. Because we are in the Milky Way, and that's the thing. Being in the Milky Way, we have a backdrop of star clouds here. Now, in just a few weeks, I'll be out at Devil's Tower in Hewlett, Wyoming. And I'm going to be doing a talk. But also, on Friday night, they told me today, I am going to be running a Skywatch out there. And the Skywatch is going to be in the evening under a sky that has no light pollution. So there's a very real possibility, and this is true for anyone who's never seen a dark sky. There's a very real possibility that people will get disoriented and not even be able to see the simplest constellation. Like, you know, you want to see the Big Dipper? Good luck. Okay, because out there it's lost amongst all the other stars. Okay, this is what happens under big sky, and it's not limited to just people watching me. It also happens to me. When I go to extremely dark skies, I'm disoriented for a time because it's just incredibly vivid and bright, and there's so much to take in. So much to take in. So now this is the Wild Duck Cluster I was telling you about before, and we've seen this before. And the Wild Duck Cluster is kind of interesting. It's It's a cluster of stars that's 6,100 light years away, but it's about the size of half the full moon or so. A third the size of the full moon actually, overall, and so it has a brightness of 6.3. So you wouldn't see it with your eye unless you were in a really dark area, and you might just look up and see this fuzzy thing up there, and that's exactly what it would be. It'd be the wild duck. So we had fun with the wild duck tonight. And now let's see. Let's go. We're gonna head up now to another favorite of mine. We're gonna going further up the north to the Milky Way. More Milky Way ahead of us. Almost overhead, in fact. And let's do a 4K video. Let's get this out and do. Oh, there it is.
Ron wants to know how they all stay away from hitting each other.
What's that?
Big clusters, big groups of stars like that.
Oh, well, that's actually a very interesting question, because they are, in some cases, like in globular clusters anyway, they are gravitationally bound. So, you do wonder how that happens. In fact, there are cases where the stars may very well run into each other and collide. And we're not actually sure of stellar collisions that have actually occurred, but we do know that they've had to have occurred, and we can see the results of them. Many times one star captures another, and then it may start to use its gravity to actually leach material off of that star. In a sense, those can become what they call vampire stars, right? And that's sort of an amazing, amazing, if not frightening possibility to think of, Alright, I'm doing, just so you know, I'm doing 15 seconds at 12,000. No, I'm not. I'm going to do it at 8,000. 15 seconds at 8,000 ISO on this object. And you kind of saw it in the 4K quickly. Looks like an hourglass. Fairly large. You'll recognize it immediately, I think. Oh, wow. Whoa.
Well, you gotta give me a few seconds for it to come out.
Holy cow, that's just something else. That's just beauteous, man. That's gorgeous. Wow. Yeah, you'll see it in a second. Everybody in the chat's already seen it.
Well, they're seeing it with me. They just won't hear me seeing it with them, but I type it in with them. This is the dumbbell nebula.
You got it. This is the dumbbell.
M.
Go ahead.
Oh my god. I don't know. 57?
No, that's the ring. But close. We're gonna see the ring next.
Oh.
See, we're going from the southern Milky Way all the way up to the northern Milky Way, and we're gonna try to look at the Veil Nebula again, the supernova remnant in Cygnus.
Well, actually, Daryl said with whatever he sent you, you could borrow for a month or 2 or 3 as long as he gets it back. No worries. He is waiting for your reaction when you really see the Veil Nebula.
The Veil, yeah, I know.
Yeah, so.
Daryl, let me tell you, you have no idea. Okay, I'm already planning when I'm gonna stay up all night to film or photograph just the Veil all night long. And to be honest with you, I owe, I feel an obligation to the SkyTour, and it's really hard on a clear night to think about doing something only for me. I really mean that, because I want to always be out there doing these things for you guys, and it just makes me nuts that I don't have all the time in the world. I wish I did. All right, let me go to 4K for a minute here.
Yeah, you said you were going from south to north. Ron wanted to know, can you see the Northern Cross cluster?
The Northern Cross. Well, that's Cygnus, the Northern Cross.
Okay.
And that's directly overhead right now. Looks beautiful, of course. Are you talking about that? He'll tell me.
The Northern Cross, yeah.
Okay, 15 seconds at 8,000 ISO. And this one should be a keeper of the dumbbell, which is measure 27, by the way.
Oh. You got the 7, right?
Yeah, that's true, actually. You did. I guess I should give you some credit.
And a 5 could be a 2 backwards. Dyslexic with numbers.
Oh, yeah.
Well, okay, well, I knew it was the dumbbell. And, well, I mean, I knew it was a Messier object.
Wow.
That's got to count for something, right? I wouldn't have known that a few months ago.
Yeah.
I didn't know who Messier was. Well, I knew Messier was a hockey player. See, I'm in Canada. My Google came up. He was the first one that came up on Google when I typed in Messier for a link.
Gotcha.
Google's funny.
Well, yeah, look at this. The dumbbell here is just beautiful. I mean,
I love the colors.
yeah, and
You couldn't have picked prettier colors on a paint palette.
no, and the nice thing is, that bluish color you're seeing is actually kind of a green, in reality. That's actually what's called oxygen 3. That is triply ionized oxygen. O3, you know, 3. And that's something that's very it's a kind of a forbidden transition. You know, you never see it here on Earth, but you only get O3 is very common in planetary nebulae. You know, if you remember the Ring Nebula has a similar coloration, doesn't it? And you'll see doubly ionized hydrogen, H2, on the fringes of the dumbbell. There it is. You see the red. Okay, you see that red? That's doubly ionized hydrogen out there. And then in the middle is oxygen. And again, the star is actually causing that glow because it's causing the atoms of the O3. It's actually triply ionizing the oxygen, and as the transition back down to a lower energy state of the atoms occurs, they give off a little bit of light. In the oxygen's case, it's a little bit of a blue-green. In the hydrogen case, it's a bit of a red, okay, when it goes from a double ionized state. So that's neat. And you also notice that the hydrogen 2 is sort of on the outside. Doubly ionized hydrogen is on the outside. It doesn't mean there's no hydrogen in where the oxygen is, but the oxygen's transition is dominant, and thus you see that. It's just, you know, astronomy's great, man. It's just understanding. You have to understand chemistry. You have to understand Earth science. You have to understand the night sky. You have to understand where things are in the sky. There's a lot to understand about astronomy, and the thing is, you never stop learning. You never stop. Wow, man, this is just stunning, guys. This is just crazy. And I'm like, here I am. I'm not even. Now I'm in full screen mode finally on my monitor in here. And that's the other thing too. I use a monitor rather than use a you know, just looking at the camera, because I don't know. I guess I just like the ability to transport the imagery elsewhere, and that's what I do. I'm transporting the imagery to the computer and thus to you through that broadcasting software. So I just kind of like how it's happening live. We're seeing the night sky live, and someone who's in say Australia could be watching this and seeing the night sky occurring right before their eyes, and it's thousands of miles away, and it's live and uncut. It's just beautiful. Even though we have a lot of moisture in the air tonight, I do have, at the zenith, I have a significant amount of Milky Way. So that's really nice. Look at that. Oh man, let's go back to that. Look at this, guys. This is just beautiful. We can zoom in on that. Look at the intricacy. Look at the intricacy in that nebula. And you can even see, wow. Holy cow. You can actually see some really interesting very, very interesting dark tendrils and light tendrils in there. Wow. I'm very impressed. What can I tell you? I'm loving it.
Now it kind of looks like kind of black in the middle too, kind of like circly, but then kind of like a band. Is that clouds or not clouds? Is that
in the middle? You mean?
Yeah, like around like. I'm trying to see because it keeps flashing on me. It keeps.
I know that's because
you're taking another picture. Yeah.
But you should see it now. You'll see it in a second. It's gonna stay up there for a minute.
When it was zoomed in before, really closely.
Yeah, let me do that
It
again.
looked kind of circular, and then it's like we could see a white star in the middle. Yeah.
That's right. That's the central star.
Back.
Yeah, and you can actually see the areas. This shows you that the makeup of this this stellar envelope. This is the discarded stellar envelope on the outside of the star. This envelope on the outside of the star is actually not homogeneous. See what I mean? It's not at all. You can actually see that it has a lot of knots and variations. Now, the interstellar medium into which it went and flowed off the star was also not homogeneous and had dark areas of gas and dust in there as well. And so in collision with those, that does change the nature and the look and the topography that we see of these objects. So I am going to go...
But it looks kind of black around that central star, though.
It does. There's like a little bit of a void there. And the central star is actually very, very hot. So it's very likely that the central star has created a... an area around it that's very, hot. Okay. And so, thus, its strong stellar winds could tend to blow dust and debris and stuff out of that region. Okay, just for fun. I don't know if we're going to get it tonight because of the nature. It's not as clear a night as the last time, but 15 seconds at 12,800. That star in the middle of the screen is one called 52 Cygni, and it's a prominent star right near that long wisp of the Veil supernova remnant in Cygnus. This is about as straight up as you can get, so I don't know what we're going to get. Oh boy, it's there. And this isn't even at a... Wow, holy cow. That's amazing. You can actually see it. Wow. I'm liking that. So just a little bit more, time, and I'll have it, I think. Let's see what we get. Let's do 30 seconds at 12,800. Now, what's interesting is that the Veil supernova remnant is actually the veil itself represents a fairly large sky, a very large area. I mean, it's literally 70 arc minutes in diameter, basically. So, what does that mean? It means that it's over a degree, doesn't it? It's over a degree of sky, and that's what it is. It's. Oh wow! Oh man! Okay, we're gonna do another one of those. It's over a degree of sky in size, and so the veil is very, very extensive, and you're seeing an expanding cloud of stellar remnant from a supernova explosion. So, I think it's really neat when you look at supernovas. That the absolute cataclysm that occurred to make that is just, I think, beyond words. If there was a stellar explosion of a star near us, like Sirius or Vega, 26 light years away, it would be incredible. We would see Vega as the brightest star in the sky. We'd see it during the day for a period of time. And then as the brightness waned, then we'd see a cloudiness around the star at night. And then that cloudiness would give way to distinct looking sets of filamentary structures, probably. And those filamentary structures might be similar to what you're about to see here as soon as this picture comes back. All right. And that filamentary structure would be kind of like this, you know. And this is exactly the same type of thing, you know. That filamentary structure occurs just because of the fact that, you know, we're looking at a non-homogeneous explosion spreading out into a non-homogeneous interstellar region. And it's so cool. So much to learn, so much to do. I'll tell you. That's wonderful. And Daryl's looking at this probably going, just wait till he sees this with a filter. And you're probably right. Because an O3 filter is going to really show this in a much, much brighter, more high contrast, better way. I don't know what to say. It's going to be fantastic. One more at 30 seconds, and then we're going to move on to the other side of the veil.
Yeah, I can see the dark ribbon going through it, too.
Right. This, you know what?
I'm getting better at recognizing, like, dark little spots or...
Yeah. I'm impressed. I'm impressed.
Oh,
I'm impressed.
If I can pick up like one or two things each stream,
yeah,
that's a good thing. But
yeah, the other thing about this this supernova remnant is it's only 2,600 light years away. It's not really a massive distance like we expect, you know, and that's okay. But still, I just think that it's very cool. Where it is as it is. Okay, now we're going to go to the eastern veil. Right now.
And also, Maddie wanted to know if you can see the zodiac light from your location.
That'd be zodiacal light. That's no. Zodiacal light is actually an interesting light because zodiacal light is the actual light that is given off by the dust in the plane of our solar system. And it's very faint, and you could see it if you know where to look. And usually before the sun rises and after the sun sets on the opposite side of the horizon, you see it as a interesting peak of light that comes up from the horizon. Almost looks like it could be faint sky glow from a distant city or something. But it goes up to a kind of a weird, strange peak, and you're actually looking at this. Oh my God! Sorry, I just gotta leave that out. That's beautiful. It goes up in a peak, and actually looks kind of like a strange.
Leaning pyramid.
Yeah, kind of pyramid, but rounded at the top. And that's actually the zodiacal light, and when people see it, they're really amazed, you know, because it's something that's, you know, they've never seen before. I'm actually going to go up to 20,000 ISO at 30 seconds here. I just want to see what I get.
Yeah, I remember you telling me about that before, when the sun either rises or sets. So look in the opposite direction, but I forgot what it was called.
That was actually
I thought it was going to be a shadow or something.
It was. That's the Earth's shadow.
Yeah.
Yeah.
Okay.
That's the Earth's shadow. You're not talking about the. You're not talking about the. What's the word?
Zodiacal.
Yeah, zodiacal light. Yep.
Zodiacal.
Yep. Oh. Okay. You know what? We're gonna take a few pictures of this one, but I just want you to look at this. This photo, you kind of see the richness and the colors. You can actually see in this nebula, this remnant, this supernova remnant, you can see the blue and the red together. Is this not beautiful?
I do see the distinct red trail.
I mean, you can see the difference right there. Holy cripes, this is beautiful. Alright, I'm just going to take another couple of photos of that. Hope you don't mind.
I don't think anyone minds.
I hope nobody minds. Yeah, thanks for indulging me on this, guys. This is just, it's just so beautiful that, you know, I'm glad you're with me when I'm doing it.
And again, check out SkyTour LiveStream with Mark D'Antonio on Facebook, and all the pictures he is taking right now, live for you, will be up, I don't know, in a couple of days.
Yeah.
Get it together, and then play around with them and see what you see, and use it as wallpaper or print it out. Be creative.
Exactly. Wow.
It's free. It's at your disposal. I mean, do it.
Heck yeah. All right, I will. You've convinced me. I'm gonna go.
Okay.
I'm gonna go look. I'm gonna go there.
And you can actually now follow Mark on Twitter at FX Models.
Yes, thanks to the urging from Amanda.
Oh, months and months. But finally, it worked.
I had a Twitter account, but I never used it.
Oh, I barely use it either, but I don't know. Maybe people can start tweeting you questions, and
Sure.
you can answer them, and we'll start trending, and
Wow.
tweet out to your favorite scientists or astrophysicists or whoever you want.
Just, I'll tell you, this is a very, it's almost an ethereal thing. I'm amazed at what I'm actually seeing, because I don't ever get to see this kind of stuff, you know? I mean, this isn't, I don't know, I mean, maybe because I built the building and I got the instrument that can do it, but to see that we're seeing right on the screen, to see that is just so, it's a delicate structure no one will ever see. Most people living today have never seen this, and they won't, because they choose not to look up. And even if they did, they couldn't look up and see this. Even in the darkest sky, they couldn't look up and see it. They'd have to actually see it like in a book and pictures and whatever. And frankly, I just don't know how anyone could go through life without looking up in the sky. And yes, I am looking up now. You can tell I am. Just as beautiful, man.
That's an excellent point, too. To think how rare these shots really are to the general public.
Yeah.
Or not even out of interest, but just out of, I mean, I don't know people with observatories. I don't know people with telescopes. I mean, I do now, but I mean, where would I go? Somewhere in my community? No,
yeah, well,
not in my community. Not anywhere around here.
Yeah.
So, I mean, and then you'd probably have to pay an admission, and it's not like you would be able to move the telescope around yourself and have, like, a good amount of time, you know?
Right.
But this, I mean, you take live requests. If it's up and you can see it, we do it. I mean...
And tonight has been a Milky Way run. We've been going from the southern edge, southern Milky Way, and going north along the Milky Way. And we still have to stop off at the Ring Nebula too. I haven't got to that yet. We did the Dumbbell, we did the Veil. I want to do all the nebulae because it's a good night for it. And even though, like I said, it's a moist night, though it's a little bit wet out. The grass has been wet for hours, in fact. But even so, it's really, really nice out, you know, for astronomy-wise. Look at that. This is just beautiful.
Safe travels to Daryl, who's taking off. He's on his way somewhere where he can see the eclipse tomorrow. So, taking off tonight. Very safe travels. Best of luck. And anyone who's staying home or won't get a very good view themselves, you can check out P&K Space Imaging. They are going to be live streaming from 2 different locations, and I believe Mark may be joining them.
I will. I'm going to be joining P&K at around 11 a.m. Eastern Time, and we're going to go and take a further look at the eclipse. We're also going to talk about futurism, because there's not much you can do when you're watching the sun get a bite taken out of it. But, you know, it'll be fun. And we'll have a good talk. We'll have a good time. So if you want to join me over on P&K Space Imaging tomorrow at 11 a.m. Eastern Time, we can have a great conversation. And, of course, the chat will always be active over there, and we can take questions. Amanda will probably be there.
If I'm awake, I would love to be there.
Yeah, well, you were awake at 11 a.m. this morning. Didn't we talk? Because I was actually frantic. I got to tell you, folks, but today, the last couple days have been kind of a blur for me. Because...
remember to breathe when you retell this story.
Well, because my main office computer ended up crapping the bed, and I had an awful lot of stuff on there that I did not want to lose. I'm going back, by the way, to the Western Veil remnant just because I'm going to take it in another set of just a little bit differently. As I was actually I had just turned it on, and it came up, and a message came up on the screen. That's all it said. It said, "NT loader not available." Huh? Press Control Alt Delete. It's like, wait, what? It turned out that my computer drive, the hard drive, just decided that it was done. And it was only a couple years old, so I was like, oh, this is maddening, because this isn't supposed to happen to a 2-year-old hard drive, maybe a 10-year-old hard drive. And then I have to think about the fact that in my special effects shop, the computer that runs a laser cutter just died out, and it has been running since 2004. And it's never been shut off. It's been running continuously since 2004. You heard me right. 2004. Okay? Ooh, that's beautiful. And since 2004 is, you know, a long time. And then only after 2 years, this computer hard drive dies, and I treat it far better than the one in the shop. In the shop, you know what? I opened up the computer. There was a mouse nest in there. On the graphics card, there was a mouse nest. The mice were sitting in there and getting warm in the winter. And hey, you know, they didn't short anything out. They knew enough not to pee on the board, because they would have gotten probably shorted out their, you know, their bodies. But that's interesting. And that computer was like a tank. It lasted. Oh, this is so beautiful. It lasted like forever. And then all of a sudden, you know, 2 years goes by, and this one has a fit and decides it's going to give up the ghost. So what I did was, of course, I had communicated to Amanda, because we're talking about streaming. It's not a streaming machine, but it is. If I do the like the Universe Sandbox 2, that was the streaming machine we used, and so I did not want to be without a machine for doing that streaming. And it made me nuts that it was not functional. So I took the hard drive out of it, and I put it onto another machine I have. I always have I've got machines like you can't believe. So I took a machine that I use for 3D printing, and I attached the hard drive from my work machine, that's the main machine, to that. And it couldn't even see the hard drive. It's like, oh man, so what's going on? So I rebooted the machine several times, and finally it saw it. And finally, after seeing it and not being able to do anything with it, it finally started doing what's called a check disk. It started looking at all the sectors on the drive to see if any of these, of them were worth saving. And it fixed a whole bunch of stuff, threw away a whole bunch of stuff, and I thought, oh, it'll never boot now. It's probably all destroyed, you know. And then I put it back into the computer, started up, and it says just as before, NT loader not found. Oh, great. So it fixed, like, it took 4 hours for it to fix all these problems. And this was now over 2 days I'm doing this. And over 4 hours it took to go through the check disk system, check disk program. And I plug it back in, and it does the same thing. So I said, you know what? Let me just try. These are SATA cables, SATA cables. I just swapped a cable from another cable that was loose in there. I said, just last ditch, I'll try that. And I started it up, and I even looked away because I was like looking at another computer because I figured I didn't have to worry about it. And all of a sudden, I heard the Windows logo and the little song. I'm like, what? I looked over at the computer. It was booting fine. So all of my troubles, you see, that now the hard drive was having a difficulty. There's no doubt. However, all of the troubles really stemmed from the SATA cable that went bad in the machine. And that doesn't usually happen, but it did. So I had to look at it as, okay, as Amanda says, breathe, breathe. Oh, this is a beautiful filament. That's 52 Cygni right there in the center. And then you can see that very, very tenuous filament down there. That's just beautiful. Whoops. That's beautiful. Now the other thing I'm going to do when I get this in the system is I'm going to when I go to modify and change the colors and so forth, I'm going to have to do what's called color correction, because obviously it has a sort of a purplish cast here. That's a function of the filter. So it imparts a false color a little bit, so we have to correct for false color. But no worries. My quadriceps are killing me. I've been standing for hours, and it's like I forget to sit. You know what I mean? Okay, let's see what we got here. One more. All right. For those that don't know, there's a, I'm still recovering. I mean, I'm 2 years, just over 2 years out from having had that surgery. But the problem is it didn't turn out to be routine after all. I ended up having, 2 heart valves replaced, which is, I've told you before, I think. And I don't want to belabor that, but so gorgeous. Having had 2 valves replaced, they were infected. So when I finally did wake up, it was about 6 or 7 days after the surgery, because I was in a coma. And when I finally woke up, I couldn't see and I couldn't move. I didn't know why, because I was kind of just sort of in my body thinking, well, I'm just waking up from the surgery. I didn't realize how much time had passed. And then that's when the doctor came in and told me that there's a clot that got away from them, and I ended up having 6 strokes on the operating table, and they just exploded in my brain like a shotgun. And they were convinced I was going to be a quadriplegic and blind. So, and I heard them say that too while I was a quadriplegic and still blind. I heard the neurologist on my left talking to my family on the right, and I couldn't see them. I could just hear them. And I was still in this, the coma, at least they thought I was. And I was actually wide awake through the whole week or 6-7 days of coma. I was wide awake for that. I heard everything. I heard the passage of time. I heard different voices. I knew who was when, who was on, whose shift was on and whose wasn't, because I recognized the voice of the different nurse. And the way they walked. Oh man, when you don't have your eyes, everything else makes more sense. So it was amazing. So as I was sitting there, and I know this is a SkyTour for astronomy, but this is a little aside. So I was laying there, unable to see anything, and I had thought that 5 days went by, and I heard the doctor saying that we're going to try and wake him up after 5 days. I heard him saying that. And then when I heard the doctor saying on my left side, but we think he's probably going to be a quadriplegic and blind, I started trying to move my legs and my arms, anything, and I thought I was. And I never heard anything. So I was like, wait, maybe I wasn't. So I thought, I guess I'm really quadriplegic and blind. And this is it. So I started to figure out ways to get around it. I figured if they could communicate with me somehow, then I could figure out a way to neurally link an electronic device to my brain to stimulate my visual center. So maybe I was starting to like synthesize a whole way around not being able to see, and to come up with some kind of artificial vision. And I was mad because it was the kind of thing you should really do if you can see. So but when I couldn't see, I had to somehow communicate that to them. But I couldn't talk because I also had a tracheotomy, so I had a hole in my throat there, and I had to breathe out of that. So I couldn't even talk. I couldn't say, "Hey, I'm in here. I'm still alive," or I hear you talking about me. I'm not in a coma. I couldn't. I tried to communicate constantly, but it didn't work. But I remember the day I woke up and I could see. And here's how it went down. I was seeing blackness. And I knew that it was day because I could hear the nurse talking, and she wasn't, it was the day nurse, the nurse that was in there for the daytime. And then when I was laying there, and it was just black, my brain started to fall asleep again. And this was still in the coma. And so I went to sleep, and I drifted away, and then I came back. When I came back, I opened my eyes automatically, and now it was a very different scene. All of a sudden, I could see, but it was sort of blurry, like looking through Vaseline at the world. Like imagine Vaseline filling your eyes and seeing that way. That's what I saw. And it was really incredible. So as I ended up, this was beautiful. I'm gonna move on now. We're gonna go to the Ring Nebula. So when I looked at the at anything that I could see, I couldn't move my head because it's still, I was suffering from some kind of issue there, quadriplegic stuff. And so as I tried to look around at anything, what I noticed was that I saw a blur, this sort of a weird blur. And that weird blur was exactly the kind of thing that I thought that I was going to be stuck with for the rest of my life. And then something happened. The nurse came in and wiped my eyes. And she wiped out the stuff that they put in your eyes to keep them from drying out when you're in a coma. And I was like, oh, I can see. I really can see. Now it wasn't really good vision, okay, because I had I was at quite a deficit because all my vision was compressed into the tiny little area in front of me. But it was really interesting to see to be able to see the anything at all. And I was able to see some stuff. And let me tell you, that was just an amazing experience. I was like, wow, I can't believe I can actually see. So then I realized that, all right, I can deal with this. I might be a quadriplegic, but at least I can see. And then as time went on, the ring's got to come up now. As time went on, I began to think about, trying to move my arms a little bit or my legs, and I would just focus on them, looking at them and thinking, all right, I'm going to move something. And nothing would ever work, and I'd never get anything to work. So that was kind of bad. But in the end, I started to get like an arm back. My arm started to come back. And so I decided to move my arm a little bit. And then I'd see a nurse. And I still couldn't turn my head because that was still all frozen. And she'd look at me, and I just look down at my hand with my eyes. And I keep going back to her, looking at my hand. And she'd go, something with your hand? And I'd blink, and she goes, okay, what do you want? And then it became like a game. And she's like, well, tell me what you want. Tell me what you want. I said, show me, show me. So I actually told her, I said, hey, in my head, I'm talking to her. I want something in my hand because I want to be able to, exercise my hand. Well, the ring looks beautiful. Central star is there. That's pretty. And so she actually got me 2 red rubber balls. And these 2 red rubber balls became my exercise balls. And I would squeeze them, and she put them in my hands, and now my right hand was dead. So it could just, but because my hands were contracting from the natural atrophy that's occurring in the muscles, it was squeezing the ball by itself, so it wouldn't drop. So what I did was I ended up squeezing that ball and over and over and over and over, and I ended up being able to. Okay, that moved a little. No, did it move? Sorry, I'm just looking at this. That's really pretty. So I ended up getting the grip strength back in my hands just because the hand that didn't have any motion at all started to respond to the fact that I didn't have any muscle control. It started to respond to the object in the hand, and so I started retraining the brain, and the brain started to say, hey, there's something there, let me squeeze it. And so over time, it took about 4 or 5 days, and by the end of that 4 or 5 days, I had grip strength in both my hands back, both of them. And it was like, that was sort of a signal to the brain that everything was going to start working again. That's pretty. And that the end would, and then I would actually be able to, progress from there. So my legs were still dead, but I figured, okay, I'm a paraplegic, not a quadriplegic. All right, I can deal with this. However, I didn't have to, fortunately, because I could actually ended up having the legs come back too. And I'm going to tell you a story that's really funny because it's the funniest thing that ever happened to me in my life. And it was while I was in the rehab hospital. And here's what happened. Now my 2 sons were with me. And I mean it now. This was the funniest thing that's ever happened to me in my life. I was in shorts, regular shorts. I didn't have to wear a Johnny coat or anything like that because, I was in a rehab hospital at this point. And I was walking on with a walker, okay? And the walker was like the life-saving. Without the walker, I couldn't handle it. I'd fall down or whatever. Well, anyway, when I started to walk forward in the walker, I was actually in what's known as the gymnasium there, which is actually just a small room, about the size of a very large living room. And there's people all around. There was about 30 people in there, so it's kind of crowded. And the nurse is at the other end. She says, okay, can you walk to me? And there's a nurse right behind me to prevent me from falling over, and she's following me with a wheelchair. And then on my left is my son. And I'm walking and walking, and I felt them going, all right, but I couldn't stop it. My shorts fell down to my ankles, and I just went, whoa! And I started laughing, and I couldn't stop laughing. And the nurse bent down very quickly and pulled my shorts up, and I started laughing so hard I couldn't even stand up anymore, and I had to sit down. I just thought that was so funny, because it's like, it's the exact kind of thing that would happen to me. But you know what? It was very funny. And then right in front of me, there's this little old man sitting in there, looking right at me with his eyes wide. Okay, and I was like, you got a good view, didn't you? And he went, uh-huh. He was nodding very slowly. I was like, oh my God, that's hilarious. So that was kind of a funny event. So, it's a silver lining amidst the, the difficulties. So, that was kind of the thing. But you know what? If any of you...
Well, it's cool that you can laugh about it.
Oh, sure. It was like hilarious. I tell the story I'm telling the story to a lot of people right now, right? In this chat. And they're probably like, oh man, I'd never admit that. It's like, oh, I can't wait to admit it. It's hilarious. You know. Then I ended up, this is beautiful. This is the Ring Nebula. I'm shooting at 20 seconds at ISO 5000. And I'll show you another photo of it when we get it. This, I was trying to refine the photos to see which would be the best. So this was an interesting couple of years, let's put it that way. And then as a recovery task, part of my rehab, I decided to build an observatory with a 300-pound telescope, a 200-pound steel pier, building segments that weigh their own 50 pounds apiece, whatever. And I decided that what, there's nothing like a good motivating project to get you back on your feet again, and that's exactly what this is. So I feel like this motivated me, and here I am.
Yeah, everyone's really glad that you're doing better. Healing thoughts are coming in from everybody. They appreciate you sharing the story. They were in shock, but obviously you're here telling the story, so they knew the outcome wasn't going to be too bad. But
yeah, my family was already told I wasn't going to survive. But then, guess what? Ta-da! I'm here like a bad penny. I keep coming back. But thanks, guys. I wasn't telling it to you, for the sympathy thing. I was telling it to you because
it's an inspirational story.
Oh well, I've really felt like going through this. And I gotta, and this is gonna be difficult for some of you guys to hear, I think. Maybe not. I'm a science guy, so the weird stuff that happened to me during this time, that stuff doesn't happen to me until it does. And then, so, during the time when my heart was stopped, and I was on the table, unconscious, being operated on, I was no longer in the hospital. I was suddenly in New Mexico, and I was with a Native American kid. My mother was Native American. She was Passamaquoddy. And he was with a woman who I never saw. I never saw her face. And he said that he was there to get me through all this. I was like, what? And I was sort of like going along for the ride, thinking this has got to be some kind of hallucination. I'm a lucid dreamer, so when I hear or I'm experiencing a dream, I kind of just put it into terms I can understand. And I even thought, well, in this dream, I thought the anesthesia is making me hallucinate. And I said that to him. I said, you know what? You're just a hallucination, okay? You're not really here, okay? And he put his hand on my shoulder, and I have to tell you, I got a really creepy feeling because I felt it. He says, this is real. He says, this is real. You better pay attention because, your life depends on this. And I go, what? What am I doing here? I'm supposed to be in surgery right now. You abducted me from a hospital. This is real. And he just kind of rolls his eyes. And I remember every detail, by the way, of this incident. It was 3.5 hours long, and I remember every single minute, every second. I could tell you exactly what happened, but I won't because it's 3.5 hours long. But in any case, the bottom line was I was in this. It started out with me in this house, and I recognized the house. As I know what the house looks like. I can draw it. And I was in what's called a root cellar, which is a area under the house where they were storing some vegetables and stuff. And in there was sort of like these nursery carts, metal carts, and they had these clay pots on them. And there was a little orange leaf that circles up on the left and a green leaf on the right, circling up on the right on the middle of the clay pot, like a little design. And it had something in it, some kind of not flowering, but a green plant. And there were about 50 of them on these carts, and I didn't know what they were. And thank you, by the way, for indulging me as I take pictures of the Ring Nebula here. And as I looked at the, let me make sure that looks good. As I looked at the carts, I realized, I don't even know what's on those carts, and I started to mouth off to this kid, okay? And I said, look, I go, why the hell you got me here? I'm supposed to be in surgery right now, and you've taken me out of the hospital. What the hell's going on? And he says, you got to calm down. You've got to calm down. We're here to take care of you. You're going to be all right if you could just follow our lead. I go, follow your lead? I don't even know where I am. And he just said, look, you just got to trust us. And I didn't trust him. I didn't want anything to do with him. And so that said, I ended up being kind of a pain in the butt. And finally, you know, I got to the point where I was really getting antsy. And so he took one of these plants in the bowl, in the pot, okay, and he lit it on fire. And he wafted the smoke at me. He said, breathe this. And I go, what do you mean breathe this? What the hell are you doing? And it was peyote. And when I smelled it, I said, I don't do this. I don't smoke this crap. Get this out of here. And he goes, look, you've got to just calm down. Breathe it. So I did. And I did calm down. It actually did feel like I felt more calm. So he basically told me that I have to, you know, pay attention. I've got to actually be real diligent with them and just focus on what they're saying, because it was important. I was like, oh, whatever. You know, whatever you say, I don't care, you know. And so I ended up, after that, I ended up just relaxing. And then the woman comes in, the woman who I never saw her face. And she says, we got to go, it's coming. I was like, what do you mean, where are we going? And this was modern, by the way, okay? He was dressed in jeans with a cloth belt and like a blue t-shirt. And he had long, you know, hair kind of down just past his shoulders, straight brown. And these two little feathers through, right by the sides of his head, right by the side of his head, two little feathers that wound down one side then the other through his hair. So that's the way I knew that he was Native American. I mean, he kind of looked it. He had a big toothy grin, brown eyes. I could draw him too. I see him very clear. Well, anyway, I ended up you know, mouthing off at him a little, and they said, you know, okay, man, we got to take him now. He's got to come with us. And I go, what? Where am I going? And they said, you're coming with us. This is important. We're doing this for you. I go, what are you doing this for me for? I said, who the hell am I? I said, you know, you stole me. You take me the hell out of my out of surgery. I'm supposed to be in surgery right now. Look what you're doing to me, for Christ's sake. This is, you know, you guys you're nuts. And he said to me, you're just gonna have to trust us. And I went, oh, you mean trust the guys who took me out of the hospital? Yeah, I can trust you. And he kind of then he got mad, and he says, look, you're gonna have to just listen to me. You follow my lead, so just be quiet. He never told me to shut up, which I thought was interesting. So anyway, after that, they brought me over and they put me in a car that's a Dodge Charger. Now, the Dodge Charger was actually a car I recognized because it was from the 70s. It was an older car, and it looked it. And I couldn't move. I was a rag doll. So they dragged me to the car, and I see the hubcap, and I recognize that as a Dodge Charger hubcap. So in my head, I'm thinking, oh, okay, these are just things I understand. This is all a figment of my imagination. And I'm really in surgery right now, is how I was thinking. Well, anyway, they put me in the car, and I see, you know, I could only see just over the top, just like the level part behind in front of the back window. I could see a distributor cap sitting up there, and then to its left is a map, which I was trying to see where the map was, so I could identify where it was. And it said something about New Mexico. That's the only reason I know it was New Mexico. And then as they're driving along now, they take me out in the car, and they're driving along, and I'm getting car sick because I'm smelling car, and it's really bad. I can't see the road, but I see dust coming up, so I know that somehow we're on a road that's, you know, dusty road. So as we move farther along, then we come to a garage. And I could tell because we go into the garage, and I'm looking through the back window because that's what I could see. And I see an old-fashioned garage door coming swinging down from overhead to swing down vertical, because that's how they used to be. And I'm like, huh, what's that? And I could smell that I could tell that we're inside a building, and I could smell, you know, oil and car exhaust. And it was really making me sick. So he opened the door, they took me out, and they said, you know, we're going to wait here for just a couple minutes. And next thing you know, a couple minutes goes by, and they stick me in another car, but this time they put me in the back of an El Camino. Now, I mean, if you guys ever saw an El Camino, it's like a car that's a pickup truck, basically. It's like a open back and just a front seat, basically, that's enclosed. So they had me leaning up against the window, the back window, and I have my feet sticking out into the bed of this El Camino. It was an old car, rusty gray, and to my left was a Quaker State oil can that was crushed in the bed with me, and then in between my feet, stuck to the back of the tailgate, was an STP oil sticker, and just to my right was an old metal gasoline can that was rattling around. And they took off out of this garage with me in the back of the car, and now I could see the road. But that was even scarier than before, because now I thought I was going to get bounced out, because it was really a rough ride. And they're driving faster and more fast and fast. I'm saying, slow down, and they're scaring the crap out of me. So that said, I was really concerned, and I was kind of wishing to just be, you know, sick in the back of that other car. But, you know, it didn't happen, and, you know, they ended up, finally, they went by a few buildings. I'm going to lower the dew cap a little here. I got a lot of dew on the dew cap, but not on the telescope. I'm going to do one more object. And they actually ended up pulling off to the side, and I could actually see, okay, maybe I can see that. I'm going to go there. I could actually see that we were actually in an area where, all right, here we go. We're actually in an area where I could just barely see that there was a beautiful sunset, yet it looked like there was something wrong. It was like it was the sunset, but something was blocking it. There was something covering the sun, and I didn't know what it was. But it looked black and amorphous, and it really kind of was kind of, you know, gross looking. And so the Indian kid, he comes into the car, and he hands me a gigantic handgun, one of the biggest handgun I've ever seen. Okay, probably like a 45 or whatever, and it's an old revolver style. And I said, "Oh, very funny. I can't even use this. What do you think I'm supposed to do with this?" And he goes, "Just follow our lead." He goes, "It's symbology. You know, you're not meant to really use it, but it's meant to be a symbol for you." And I went, "Oh my God, I have no idea what you're talking about." So he ended up telling me to just bear with him. I was like, "All right, whatever you say." At that point, I was just accepting it. Like, whatever, okay. So that's what I did. And the woman came around and said, "We got to hurry, it's coming." And I was like, "What's coming? What the hell?" He said, and then I finally lost. I said, "Where am I? Why the hell am I here? What did you take me out of the hospital for?" And he looks at me. I'll tell you what this is in a minute. He looks at me and he says to me, he goes, when I said, "Why am I here? What are you doing this for?" He goes, "You're a healer. We do this for our healers." And I was like, "What? What do you mean a healer? If I was a healer, why the hell would I get myself healed? Why am I even in the hospital at all?" And he rolls his eyes and he goes, "Shut up. It doesn't work that way." And that's the first time he said shut up to me. And I went, whoa, you know, like, whatever. It's like, these guys crazy. So I did my best to basically, you know, tolerate, you know, what he was saying to me, and I basically allowed it, you know, because, hey, he knew better, so to speak. So anyway, as I found out, he ended up doing this thing where he actually came up to me and he put, like I said, he put that gun in my hand. He told me I was gonna have to pay close attention to him, and I did. And when I paid close attention to him, I listened to what he said, and he said, "You have to just trust us. You have to visualize this with us, because this is you we're dealing with now." And I honestly didn't know what the heck he's talking about. So I did what he said. At least I tried to. And they, all of a sudden, they started shooting these guns at this black amorphous object over the sun. And it started to fall away in like chunks. And I'm like, I said to him, I'm like, oh, you're getting it. I said, what? I go, I don't know what it is, but okay. I mean, it's really loud, though. I mean, you got to understand. So it's like, bam, bam. I mean, really, really loud. And then he basically, it all falls away, and all of a sudden it's a beautiful New Mexican sunset again. That's all after about 10 minutes of shooting at it. It was really something. And then he comes over, and now he's all smiles. And the woman, I never saw her face. I can hear that she's happy too. She's giddy almost. And he comes over, he puts his arm around me, he says, "You are going to be all right." And he shakes me in like a good way. He says, "Oh, you're going to be all right now." And I went, "What do you mean all right? I don't even know what the hell happened." And he goes, and he laughs. He goes, "Oh, you'll find out." He goes, "But let me tell you." He goes, you were a hard one." He goes, "A hard one? Hard what?" I honestly didn't understand him. And he goes, "Don't worry. When you finally come out of this, you're going to be fine." He goes, "But we're leaving now. Okay? We did our part. So we're done with you right now." And I went, "Oh, for crying out loud." I said, "I mean, I'm never going to find out what this was?" And he goes, "Oh no, you will." So then when I woke up and I was, I could see again, and the doctor was testing my vision. I was in the hospital at that time. He leaned over to me and he said, "I told you that I'd be honest." And he goes, we operated on you, and of course, as we said, but there was a problem. We ended up, missing. There was a clot in the heart, and it got loose. He said, "But the reason you're here and the reason you survived is because for some reason it blew up into 1,000,000 pieces, and that's why you're here."
It's crazy.
I was blown away. And I couldn't talk because I had a trach, so I was going. All I could do was breathe fast. And he goes, "Well, but you're gonna be okay. We think you're gonna be okay now. You just, probably need to get some therapy and rehab, and you'll be okay." They never expected I'd be able to see properly, and they never ever thought I'd be able to walk again. They told me that. They said, "Don't expect, this because it's really bad." And they took all my family in to see the CAT scan of the brain. And it was just a literally Swiss cheese, where it had been attacked by this clot. However, the fact that I had survived was kind of interesting because I wasn't supposed to, and they didn't think I would. They were convinced I wouldn't, actually. Let's go. By the way, Amanda, this is the Cat's Eye Nebula, which I think you like, right?
I love it. I'm not sure if Duplicate's still in chat. He was the first one to suggest it, and wow, what a winner he picked.
Yeah, I know you love that color. When do we get the...
Oh, it's so bright. It's hypnotic. I don't know. I don't know why. It just seems so bright and such a gorgeous color.
I'm glad you like it.
It does. It pops right off the screen.
Yeah. And it's just, the sky is just beautiful. It's really wet out though. I'm literally, water's dripping off the dew cap. Dripping. It's
dripping off the telescope.
Yeah. It's crazy. We
did actually have a question. Sorry, I didn't jot down the name. For the Ring Nebula.
Okay.
Why is it a circle?
Oh, that's a very good question. Planetary nebulae are born off of stars that are dying, so they tend roughly to be some semblance of a spherical cloud that will slough off of an old star as it's dying and releasing its outer layers back to the interstellar medium. However, when we look at the ring, okay, we're seeing something else. We're seeing a spherical cloud around the star, and we're also seeing an object, or we're actually seeing an object that actually is three-dimensional. So, and as I've used this analogy before, and I'm going to be moving the telescope because I believe it's covered in dew, which is why we're not seeing the cat's eye the way we should. When we talk about a ring nebula, for instance, what we want to consider is that we want to try and understand the shape. So if we consider that the ring is three-dimensional, okay, well, what is a three-dimensional ring? A three-dimensional ring, oh yeah, we got lots to do in there. That's why we're not seeing this. Let me get out my hairdryer. A three-dimensional ring basically makes no sense because you hear ring and that sort of sounds flat, and you think ring and then you think donut. Well, it's neither of those things. It's a sphere, okay? It's a sphere. And if you imagine that the sphere is thicker on the edges and thinner on the front and back side, then you can imagine how it might look. But that's not how the ring works. The ring works differently. It works this way. If you have a object that is a sphere, a spherical outflow of material, okay, from, say, a star that's died, that spherical outflow of material ends up being, say it's expanding in a fairly even way. We know that it doesn't always happen that way, but it can. In the ring's case, maybe it did. So now imagine, if you will, to understand how that shape could happen, how that ring could be. Imagine, if you would, that you're holding a grapefruit in your hands. And that grapefruit, you hold it on the sides, all right, in front of you, on each side, left and right side of the grapefruit, you hold it. And then you actually see, when you look at it, that you can't see through your fingers because you're looking through more fingers because they're edge onto you. Well, now, if you then consider that as you move your hands toward the front and back, and you have your hands apart like that, you could see through your fingers. So when you look at the ring nebula, you're actually seeing what could be a spherical cloud of gas and dust that only appears to be thinner because of the nature of the sphericity, that whole thing that we talked about with the grapefruit analogy. Maybe you're looking through less material when it's in the front and the back, and more material when it's on the side. So that's the reason why we might see it that way. I think that's pretty cool. That's why it's a sphere.
Oh, sorry, I was on mute. I was getting the link. A few people have to go to bed because they have lives and things to do in the morning. So I just wanted to remind anyone that is taking off, try to join us tomorrow afternoon at P&K Space Imaging. I put the link in chat, and yeah, we'll watch the eclipse, and Mark will give us some more insight, and
I'll be on at 11.
It'll be a good time. Yeah. Eastern. 11 a.m. Eastern.
Yes, correct. 11 a.m. Eastern Time. I'm heading to one more object.
There's another really bright one, like the cat's eye, that I really like. I'm trying to remember which one it is. I don't know. I can't remember the name of it.
You don't remember it?
Not offhand. I mean, I like the I don't know, blue and pink ones, like the dumbbell and the ring and stuff. I think the cat's eye so far is my favorite. I like Vega because it looks like a blue shimmering diamond.
Of course.
But there was another one. It was not as bright as this one, but it was the same. It was the same color, and it was very, very vivid. I can't remember what it was.
Ooh.
I'll let you know when I see it again.
Okay. Very good. Very good.
And for everything we don't get to tonight, I will save it for next time.
You're gonna what?
I'll save it for some other time.
Oh, okay.
There are a few requests. We're doing nebula across the Milky Way.
Okay. Okay. This lonely little object right here in the middle of the screen. This little guy. Do you notice the color when I get back to him? Hang on. I think I popped him off the screen by accident. Okay, here we go. Okay, this little guy right here. You know what that is?
Wait till it comes up, right?
That.
Still moving online. Oh,
Okay.
it's coming a little closer. A little closer. For the look of it, I want to say Vega.
It's not a star.
Oh, it's a nebula.
It's not a nebula.
What is it?
It's not a nebula. It's not a star. What's left?
Is it an exoplanet?
No, we can't see exoplanets with a regular telescope. This is Neptune. That's the planet.
Wow.
That's Neptune. Isn't that cool?
That's gorgeous. That's amazing. Oh my gosh.
Yeah. Neptune is a brilliant blue. And let's see how. And you gotta be careful when you take pictures of it because the blue gets washed out as this shows. Okay. Now, that's how big the disk of Neptune is, and that's an actual disk of the planet we can see. And when we look at this, one thing to understand is that this planet is something, for instance, that we could turn our spectral system to, and based on the reflected light from it, from the sun, the atmosphere of Neptune will absorb some frequencies out of the solar spectrum. And we could detect what kind of chemicals and what kind of elements are in the Neptunian atmosphere from the spectral readings. And that's how we have done this in the past. That's how we figured out what the planets are made of. We would take a spectrum of them and know what the sun's is, compare the two, subtract out the suns, and what's left is Neptune. And what's left is Uranus. What's left is Saturn and Jupiter. So this is how we can detect what the chemistry is. The chemistry is in these planets.
That's amazing.
It is. It's really cool. It's really cool. So
now, would that be one of the examples where, like, scientists had to create math solutions to solve the problem?
Well, sure.
Like by subtracting the sun's value
Yeah.
to get the value of the gas planet? Wow.
Yeah, they would.
That's weird. That's crazy. It's very hard to wrap your head around, but it's incredible that people can actually come up with this kind of thing.
I know, huh? It's incredible. Now, there's something else very incredible here, and that is that we see Neptune, right? And right above it, we see something very, very faint. You see that? Right above Neptune, you see that tiny little white dot?
Possibly. I think I see something, but maybe it's just wishful thinking.
No, it's.
I got pretty close.
There's a tiny white dot on there, and that tiny white dot is Neptune's moon, Triton.
I was gonna guess Triton.
And now, if you look a little bit to this side, let me just move it. Oh. What the heck? This is a photo. I'm sorry. I gotta try and see if we can zoom in this way. See if I can see it. Okay. Okay, I'll take a picture here. Same picture here. All right, and then we'll come back to it in a second. Okay, so now let's go back into the picture. Okay. There we go. So right above Neptune, you see Triton, okay? A little tiny dot, you see it? And now, to the left, over by the upper right-hand corner of that box, that magnification box that's there, right? Now right above the corner of the upper right-hand corner of that outer box, you see another dot there. You see that?
Yeah, I think I did, but then it moved.
Yeah, it did move, but that little tiny dot, which is now above the upper right-hand corner, that little tiny dot is Nereid, which is Neptune's, what's in the moon of Neptune. And then right above Neptune itself is Triton still. So there we see Neptune with 2 of its moons. Isn't that cool?
That's incredible.
Yep. Yep, yep. Really, really cool.
It's a beautiful color too. It has one of those mesmerizing effects to it too.
Yeah, that teal color is one that you often say you like a lot. So I showed you this anyway because it was fun. And with this, I think we're going to make this the last object of view, ladies and gentlemen, boys and girls, and dogs and cats of all ages. Because I'm going to be getting up pretty early tomorrow myself because I'm going to be going out to view the eclipse. I'm also going to be preparing and getting some other things done, but I also want to close out and do some final work here in the observatory before I go to bed. So I wanted to thank you for joining me, and I want to say to you, thank you so much for being attentive and letting me ramble on with my silly stories.
Everyone loved your stories. Thank you for sharing them because you really don't have to. Like
that stuff doesn't happen to me until it does. You see, that's the weird thing. And I'm not sure what to make of it. But anyway, that said, I wanted to just thank you for being in attendance tonight on this wonderful SkyTour live stream, and I look forward to seeing you guys again. So we're gonna sign off for now, but we'll be back in the next clear sky. So keep looking up, folks, and I will say good night and have a pleasant tomorrow.